Okay, if I can now welcome Natalie to the stage from the RIPE NCC. She's going to give us everything we ever wanted, security with just a single button click. So I'm definitely going to pay attention to this one. Okay, thank you, Natalie. Over to you. Thank you.
Thanks. Thanks, Andy. Right, okay. First of all, thanks for having me here. First time in Tampere. Very great to be here. Looking forward to it. My presentation, when I was asked to do a presentation, I thought, what am I going to talk about? And because at the moment, I recently changed jobs within the RIPE NCC. I used to be IP6 program manager, stepped behind the scenes to become a product manager. And last 4 months, I've been working a lot behind the scenes. People ask, does RIPE NCC have products? Well, we do, and some of them you might are quite familiar with. It's the LAR portal, it's the RIPE database, it's also RPKI, that kind of stuff. So I've been working mostly on that behind the scenes. After 9 years of BGP training courses, I learned that security is a big topic for a lot of network engineers. It's also something that they don't find very easy. And then we throw all these words at them, like RPKI, RRR, BCP38, manners, and they are getting lost in translation. And they basically just told me multiple times, Natalie, can you make this easy? We want routing security, it's important for us, but we want it to be as easy as possible. So that's something I'm working on. And I'll show you in this presentation why I'm working on that and how RIPE NCC is tackling that. Before that, a little bit of background information. So I assume most of you know who RIPE NCC is. The reason why we existed is not always exactly clear to everybody. So when we were founded, our primary goal was to make sure that we hand out IP addresses individually unique. So they have to be unique. You can only imagine what happens if we start distributing IP addresses and they're not unique. Then things get messy very quick. To ensure that uniqueness, we also worked early from our foundation on a database, the Whois database. But later on, more and more Whois databases existed, so it got a bit confusing, so we called ours the RIPE database. So not the Whois anymore. We ask our members to document their usage in that database. So basically, when we give blocks out, we make sure that they're unique. When we give AS numbers out, we make sure they're unique. And we as RIPE NCC register that in the RIPE database. And that gives our members the opportunity to create the, objects in the database that show the uniqueness of their routing, for example, through route objects, etc., etc. The reason why the date is relevant, 1992, is because a lot of stuff happened around those years. 1992, RIPE NCC was formed, but around the same time, something else was being in the pipeline. That was BGP. And also around the same time, people started working on things like IPv6. And also around the same time, people were starting working on things like DHCP. All those key elements that we all use today were basically standardized, worked on in that same era of 1992, 1995. So some of us were not even born then. Most of us do, I think. But that is important because back in those days, routing security was not a very important topic. It basically came much later where this became more apparent. In those years, most people still knew each other. The research networks knew each other. The first big ISPs, the guys working there kind of all knew each other. The thing with BGP is that there is no real security incorporated in the protocol itself. So any network can announce any IP prefix. Of course, there are many settings or BGP attributes that were built in the process. For example, communities and MEDs and stuff, ways to basically describe your routing decisions. But we all know that accidents happen. We all know somebody that starts announcing the peering LAN of an IXP prefix. We all know somebody who starts to make full route table leaks. And actually with IPv6 it got even worse. Because I don't know if you ever typed in an IPv6 address in a config, but that makes typos quite easy. Most typos, most accidents that we see are fat fingers. And that means incidents, just typos, simple typos. In IPv6, you have now A, B, C, D, E, F as well. And the 2 or 3 are close on the keyboard. Where it starts to get quite problematic is policy violations. So more deliberate stuff, where people start to hijack prefixes. In BGP, you know that more specifics win. So that means you can do quite some damage if you start announcing more specifics from another network. And that's actually what happened in April 2018. I think it was on the 24th of April, where a company in Ohio suddenly, around midnight there, started to announce more specifics, so /24s from a /23 from an Amazon DNS network. Now, you can ask, was that done by accident? But nobody believes that, because they also did a DNS hijack in the way. So it was a whole series of incidents where you could really say, okay, this was malicious. It went unnoticed for 2 hours, and the only good thing of this whole hijack was that there were only 2 parties propagating the more specifics, the /24s in this case. It was Hurricane Electric, it was Google. Luckily, all the other transit networks in the world filtered these /24s, which means that it had only an impact on 15% of the networks globally. But 15% of the networks announced basically that prefix for 2 hours. Doesn't sound long, but because there also was a DNS hijack involved, and there was a big, not Bitcoin, the Ethereum wallet involved. There was a hijack of, I think, 14,000 euros worth of Ethereums. Now, that's money. This was really the first time where we actually saw that the people setting this hijack up went after money deliberately. This is 2018, and we expect that we will see this behavior a lot more often. And with the scarcity of IPv4, at the RIPE NCC, we see not only routing hijacks happening a lot, we also see more and more administrative hijacks of IP space. People actually sending us fake death certificates to claim prefixes to their name. Because an IP address at the moment is worth around $16, one single IP address. So it becomes lucrative now to do hijacks of sorts. This kind of hijacks, or getting IP addresses on your name. So AIESEC also made a report, 2017 Routing Security Review. I digged into the numbers. It reports 14,000 incidents in a year. Now, I have to be honest, that's not 14,000 hijacks. Only 40% of them were actually hijacks. Not all of those were intentional. Like I said, the majority is still fat fingers. But still, that is quite a high number. On a daily basis, BGPmon has a Twitter account, and they announce around 12 on average prefix hijacks a day. 10% of all the worldwide AS numbers was affected in some way, shape or form. So we see those numbers suddenly rising up very quick. Where am I going with this? we have a bit of a problem here. And one of the ways to limit the scope of these problems was basically invented already in 1995 with the Internet routing registries. So let's first zoom a little bit about the routing registry databases, because they served a function, and if people would basically only filter what they should announce, a lot of this stuff would not even happen. But what's the problem with that? The Internet Routing Registry is, in our region, a subset of the RIPE database. So an Internet Routing Registry typically holds route objects. Route objects are, as I explained it to my mother, a marriage between a prefix and an AS number. You basically make a statement about which AS number should originate a specific prefix. Many of the telcos, tier 1s, but also internet exchange points, probably TREX as well, demands from their customers that they create such a route object. Now, which one to use? Because by now there are around, I'm not joking, 30 different internet routing registries. The NTT has one, RIPE has one, APNIC has one, but there are also smaller ones. And then RADB exists. RADB is, the full name is Routing Assets Database. It's a commercial one. I'll get to that in a second, what that means. But many people can choose, or people can choose many internet routing registries to create a root object in. And not all of them do holder verification. In the RIPE database, because RIPE creates the allocation and the AS number, we as RIPE-NC do holder verification of those objects. So we're pretty sure that the person creating the root object is authorized to do so. This actually works only for the stuff in the RIPE database that is from the RIPE region. But we also have a situation where basically anybody from any of the other internet registries, ERIN, LACNIC, can create root objects in the RIPE database using a well-known password. And the password of that is just publicly available. So although for the RIPE region you have to do some kind of holder verification, for all the out-of-region stuff, what we call it, you can still create it in the RIPE database, in the Internet Routing Registry, but we don't do any holder verification. I get to that in a second, why that's maybe not the best idea. Then we have the RADB. Like I said, it's a commercial database. That means that if you pay a yearly fee, you can basically put anything you want in RADB. That also opens up a can of worms. So there's not much holder verification there. And a lot of the other IRRs don't do the verification of holdership. So this routing registry stuff sounds good, but it has some flaws. Yet, a lot of people use this internet routing registry to do some automation for their router configuration. Is there anybody in the room doing that? Running your own scripts to filter from the routing registry? Yeah? Yeah, quite some hands. Yeah, it's quite common to do that. Basically what you do is you use one of the tools listed here, the IR toolset, BGPQ3, or your own home-baked scripts, to check the different IRRs for the root objects, for example, for the AS numbers or the AS sets, and basically populate some configuration for your router to make statements about what you should accept or not. And the most simple form of that is basically saying, if there is no root object, I will just not accept. But you can do more fancy stuff there as well. This only works well if the data would be correct in those databases, ideally. And this is where we start to get a little bit into trouble. Before I show you what kind of trouble, just a bit of an overview about who uses that filtering. A lot of parties, so mostly it's done by providers. I run a hobby network called ColoClue. It's a colocation for people like you that don't want to put your server in your employer's rack, but you still want control over a server and you don't want to have it in your living room. So we operate a network and we do strict IRR and RPKI filtering. So I asked the guys with the access to the router, can you tell me for IRR, when we do strict filtering, how much routes are being dropped? What do we lose if we do strict filtering? And we lose around, depending on the router and depending on the IXPs, we lose around 6% of all the routes that we get. Because there are no route objects, etc. Transit providers, transit providers tend to not filter, because for transit providers, traffic means money. Yeah. So you can imagine, if they drop traffic, they drop money. Looking at the IRR for the RIPE database, this is the coverage. The coverage is pretty well. The reason why Afrinic is so big is because until 2005, we served Africa. But if we look at the accuracy within the RIPE region is pretty good. It's around 80–90%. But if we look at the rest of the region, the accuracy drops to around 60–65–70%. So that's pretty bad. If we look at the RADB, we see that it covers most of the rest of the world. But then the accuracy. There is no holder verification whatsoever. That's the quality of RADB. As you can see, it's not really well, especially in the RIPE region. It's pretty bad. Except in Finland, yeah. Who of you uses the RADB? Anybody? You do? Okay, yeah. But you also have the RIPE database, right? Yeah, okay. Yeah.
Do you have a similar picture of AppNic?
For APNIC?
Yeah.
I do, but not in this presentation.
Okay.
I can show you.
But can you just summarize what it would show?
It's quite similar for the RIPE region, actually. So within their region, it's pretty okay. They don't allow foreign route objects. So the coverage is quite low. It's only in their region the coverage is fine, of course. But the quality there is also around 80%. Yeah. Now, APNIC started with the IRR system around the same time RIPE did. So they use kind of sort of the same setup. Yeah. So we have a bit of a problem with IRR. Over the last 25 years, we built that up. The data got stale. If I show you the pictures of the stale data, it's actually worse, the percentage, because people tend to create it, walk away, and never look back at it. So that's not so good. So we had to come up with something better. And when we came up with something better, we came up with RPKI. That started in 2011 from scratch. And it was basically designed by engineers for engineers and standardized in the IETF. It's resource public key infrastructure. And most engineers get a bit nervous when they hear PKI in the sense with routers. Because they go like, wow, that's going to take a lot of computing power, a lot of CPU. And I'm not sure I really am forward for this. But basically what it does, if you start by creating a certificate for your resources in the LER portal. So you have to be a member of RIPE NCC or be a PI holder. You go into the LER portal and you create ROAs, Route Authorization Announcements. ROAs, they're kind of sort of the same as, they serve the same purpose as route objects. And with that, you can do holder verification and you can basically import that in your router through a validator who checks the status, if that ROAS is valid or invalid, inject that in the router. But you can still manually decide if you want to have white lists or black lists, etc. Here is where people just start saying, well, if a ROA and a route object is kind of the same, why do you use two different platforms to make them? Why do I have to create a route object in the RIPE database and a ROA in the LER portal? What's with that? Can't you just make one button for that? I want to create authorization for this prefix stating that this is the origin, and just a button that says, do your magic, create a ROA, create a route object, whatever you want. And we're like, okay, that kind of sort of makes sense. Until now, we could not do that, because in the RIPE region, when you create a route object, you still needed to authenticate the AS number. So you had to authenticate both the prefix and the AS number. Recently, that policy changed to take away the authentication for the AS number. So, and that works the same in ROAS. For ROAS, you only the prefix holder can create the ROAS. So it doesn't matter which AS number you put in there. So that's now similar. APNIC already has the same functionality. They built that one button already, and they saw the uptake for RPKI going like this. Because they have easy-to-use portals, we see that this actually helps people to actually implement stuff, as long as you give them an easy way to do it. How to set up ROAS, I'm not going into these 3 slides, but basically this is in the LA portal. We show you your AS number, we show you the prefix, we show you what's invalid and valid. This one is invalid on purpose, because we use it as a beacon to see how far it traverses in the networks. And then basically you can create a ROA quite easily. Now then, if we look at the coverage of RPKI, that's pretty bad. As you can imagine, we just started in 2011. But you see coverage in some really funky places. Let's see if I can get the pointer. We have some interesting countries here that are quite far with RPKI. The reason why you see such a big deployment in South America, LACNIC does not even have an IRR. So they don't have their routing database. They use RPKI as their main source. In Europe, we did many training courses. We've been quite active and loud about RPKI. And we see some roadshows going on in the APNIC area. The reason why there's not much uptake in the US is because the US has many lawyers. And with RPKI, we have a bit of a problem there, that you can only use their, what we call trust anchor locator, basically their part of the trust anchors, only if you fill in a tick box. And we asked Erin, could we automate around it, that tick box, by making it a one-time tick box for all the trust anchor locators, and then people can automate against that, but we were not allowed so far. So we hope that they will work to improve that. Then we can get a worldwide, more automated way. Yes?
I understand that people like Google are an advocate of this technology.
Yes.
Because they are often a target of address hijacks. Don't they have any sway within that community in the US? I guess the smile is the answer.
The smile is the answer, yeah. There's a lot of people behind the scenes trying to get Erin moving forward with RPKI. Yeah. At the moment, they have another interesting challenge, because they also don't have a very well-known, wide-used IRR. And they are now working on that. So, yes.
Wouldn't it make sense for them to go follow the Latin Americans in that they could just skip the IRR and implement RPKI?
Well, you would say so. That's indeed the heated discussion du jour.
Ah.
Yes. You're not the only one thinking that way. So this is the coverage. We are curious now to see, of course, not the coverage, but the quality, because that is really what counts with RPKI. Is the data quality better than with IRR? Well, of course it is. So this is 100%, the light green. And you can see that the accuracy, of course, is still quite high. That's mostly because we don't have a lot of staleness, since the thing is only there since 2011. But also because once you figured it out, actually it's not that difficult. Now, not all these countries, so I have to be honest here, This is the coverage of organizations who created ROAS. But the true value in RPKI is not in building ROAS, it's to actually validate. So to basically make routing decisions on the stuff that is in that repository, that long list that we call Validator, that piece of software that says this route is valid, this is invalid, it comes from a different AS than that we have in the ROA list, and then make the final routing decisions on that. So there are not too many organizations daring to do that. I think there are around 6 or 8 worldwide. So that's the last step that we have to still but I have to say, more and more IXPs are taking the lead in this to actually do active IRR and RPKI full filtering. So they take a lead in this whole RPKI stuff. So the data quality is good. You can see there Finland, 20% of the prefixes have a ROA. That's 21% of all the addresses registered in Finland. Finland, 40. And 100% accuracy. Keep it that way. Keep the accuracy at 100%. So that's quite an achievement because 40% of the addresses covered by ROAS is quite high. 100% accuracy is simply just well done. So that's my message for you basically. Keep the percentage of prefixes, let that go up. So that means quite a bunch of the big guys need to create ROAS probably. But yeah, urge them to keep it accurate.
A message from the internet.
Yes.
A person called Job Snyder says that according to him, it's 40 networks doing it worldwide. Last year it was 4.
40. Oh, okay, sorry. Yeah. Thanks, Job. 40 networks doing full origin validation.
Yeah.
Okay. So if that number keeps going up like that, then we're on the good way. Then another thing that we want to make easy, because we have this box in the middle here, what we call Validator. Basically, people put ROAS in, then we build a repository that checks if those ROAS are valid. So if they are what you put in, and what we see maybe other people put in for your networks, make decisions on that. And with an API, you can put that in your scripts and basically inject that to your routers. People want that validator to be more easy. So we've been working on that. We just launched Validator number 3 with some features that we think that make your lives a bit easier to implement. One of the things we now also have is to manage local exceptions. So basically what happened, one of the networks that did full origin authorization said to us, another party had a wrong ROA and lost sight to our network. They called us and we basically said, okay, we give you 4 days to fix your ROA. Meanwhile, we'll put you on the whitelist. So you're still in control. So that's basically comes to the end of my presentation. Use IRR, but make sure you keep your stuff up to date. It helps other people. Have a look at RPKI. You're on the right way with the ROAS. Keep it up, keep the accuracy, but also start looking at the last step in RPKI and have a look at that validator and provide us with some feedback, please. That brings me to the end. Thank you.
Thank you. Fabulous. Fabulous and good advice. Thank you. I think the more work that's done on filtering, the better the internet will be for end users and for ourselves as operators as well. As long as it's good quality work that continues this progress. Are there any questions for Natalie?
Okay.
I don't see any hands up anyway, so.
Yeah, I'm here the rest
You're
of the
here
day.
all evening? Great. So we can ask you lots of questions all night long about filtering. Okay, Tarko, are you ready to speak?
Yeah, I am. I hope this works, so let's see.
Thanks again, Natalie.
Windows machine, excellent. So does this work? Okay, great. So hello everyone. I just realized my name is not on the presentation, but my name is Tarko Tikan and I come from Telia Estonia. So not really part of the big Telia family, but the Telia Estonian part. And when Alexi asked me to come here and present something, then I thought that, okay, what I've been doing in last years that's actually worth presenting, and I couldn't find anything interesting for you that's like networking related. So there is a presentation that I've done about our dual-stack IPv6 deployment in our broadband network, and you can find that in Google, so that's okay. But then I thought that, okay, I will present something that was like a weekend hacking project, how to annoy all of our engineering team in Estonia. So basically, we ran a crisis training exercise. A little bit background, so what is the technology organization in Estonia? It's basically, we have been doing DevOps in networking for last almost like 10 years. So we are like totally opposite from typical telco, where these kind of DevOps, whatever activities are done first in IT, and then maybe networking guys are the last frontier. We've been approaching this in other directions. So we actually done it in networking, and we pushed it out to the IT, basically started it with 2 years ago. And actually, we spent like most of the last year doing actual DevOps implementation and getting all the teams working well. So we have like more than 10 DevOps teams, which each have like 15 or more people. And these teams are fully responsible of, let's say, our applications and our servers and operating systems and stuff like that for their applications. So they are basically running the full stack. And we have the central IT team that's doing the data center infrastructure, for example. So yeah, we do VMs and firewalls and networking in the data center and monitoring and logging. The DevOps teams don't have to do that, but they have to do everything else. And now in that scenario, the typical problem is that, especially in telco, but also in big corporations as well, you might have like hundreds of servers, and you don't really know who owns these servers, who operates these servers. In our scenario, we have 2 IT data centers, which are like more than 90% virtualized, so we only have a little bit like physical hardware left for the teams. So most of the hardware is actually running virtualization, and we have like more than 2,500 VMs. In our scenario also, every server has a public IP address, so there are no private IP addresses, so we have like very good IP identities for the server. So it might have one or it might have multiple IPs, but the IP is very good identity. And we have CMDB as well, and then we manage all our servers via the Bastion hosts. So, and what we did is, and what I hacked during the weekend is that we ran a crisis simulation where we basically said that, first of all, we put up this web page, which is in Estonian, but what it says is, sorry, there is a crisis exercise and we have ruined your day. But now you have to take this application, which is available for Linux and Windows, 32-bit, 64-bit, statically linked binaries, and you have to run these binaries on all your machines immediately. So basically as fast as you could. And we're not giving you any other help. You have to know which machines you own, and you have to know all the credentials, and you be able to manage these machines. And the scenario said that, okay, this is kind of simulated virus exercise. So there is some zero-day virus going on in our data center on our machines, and we have this kind of cleanup application. And now you have to go through and you have to run it. And then we thought that, okay, how do we do this? We actually followed our like own crisis procedure, and we have like every week we have crisis manager and so on and so on. So we use the same technology. And the application itself, I mean, you don't have to read the code right now, but it's stupidly simple. It's just a Golang application because this enabled me to not write any code on Windows because I don't use Windows and I don't like Windows. So I could actually write a single Go binary and compile it both for Linux and Windows. And the funny story here is that I wanted to make sure that this binary can only be run as an like root user or administrator on these machines. On Linux, it's very easy. Let's say, let's just create a temp file to the root directory. If the creation of this temp file fails, then we are not the root user, and we give an error message back to the user. And the idea why we wanted to do that was that we wanted to make sure that these binaries are ran with the root users. So the teams would actually have all the root passwords and stuff like that. On Windows, it turns out it's really hard because modern Windows is making your applications like stupidly backwards compatible. So they are running a virtual file system where your application can actually write to every directory, because my first idea was to do exactly the same on Windows as well. So let's write to system disk or whatever, and if it fails, then they'll just exit. But it fails because Windows is running this virtual file system, and allows you to write everywhere. And these files are actually put in some sort of temp directory, and you can actually read from them later on and so on. It was very stupid. And I was looking for a way how to do this for like half a day. When I finally found a solution, okay, the raw socket was a solution. So if the creation of a raw socket fails on Windows, then probably you're not an administrator. So this actually failed gracefully with some sort of exception. And what this actually application did is it gathers like the host name of the server, it gathers all the network interfaces, all the IP addresses, UIDs of the user who ran this, and also the path name where this binary was ran from. And it just HTTP posts it to some central server. I didn't care about adding additional security there, and if someone was very clever, they could actually make the same posts with JSON. But the trick here is that all these posts are coming from the servers, and on the central collection site, I can see the source IP of these connections. And this way I can know from which machines these connections come from. And this the teams cannot fake. And that's basically the executive summary. So we start at 10 o'clock in the morning, and we called up the current operational crisis manager who was on duty on that week, saying that, sorry, but we ruined your day. And you should have heard his voice on the phone going like, oh. And our message was that, okay, here is an email we have prepared. We are sending you an email. In the email, there is a link to this web page. And we actually made that web page available from the whole internet. So wherever you ran that application, it would actually be able to call home. It's not our own data center, but from someone's home computer or whatever. It worked from everywhere. This way, we could actually gather statistics where this application was run from. And then it went through the typical escalation chain, whatever teams getting involved, and so on and so on. And that's actually what it took. It took like 40 minutes to actually get first server batched. And then by batched, I mean that binary was ran. And then by 10:50, we had two teams that had done over 80%, and then we had some status updates. And at 4 o'clock, we said, okay, end of the training, and then we published all data to the teams. Because until that time, the teams could only see the percentage of the servers patched in their team. So we took the CMDB data, we knew in the CMDB who were the owners, and we basically grouped by these owners and showed them percentage that, okay, your team has maybe 83% of servers patched. Which servers, whatever, don't know, or don't tell. But we made that data public at 4 o'clock, and like 16:25, our CMDB crashed because of the big load on there and people fixing their data and stuff like that. So that kind of happens. But now because everyone loves data, so I've removed the team names, but the data is still live data. So actually see the value of having an automated systems. So this is basically the timeline, how the exercise ran, and these are the percentages for the teams. And you can see that like 10:30 when the first servers were patched. So this is the same log file. And we can see that this is the first server where it was ran from. And then we can see for two teams, they actually have a salt stack masters. And they ran the binary first on the salt stack masters. And then they basically wrote whatever salt recipe they need. And then they basically ran the recipe on all of their servers. So this way we can see that like in 5 to 10 minutes, basically two teams were over 80% done. So, and I have the overall graph as well later on. But this shows the value of having an automation tools, whatever, salt stack, Ansible, everything goes. It's better than logging into manually to every server and getting the root user and then downloading the application. This is the full picture, how it ended up with. We did a couple of corrections further on because we had servers with multiple IP addresses, and I thought that I will fix this later and I will correlate them later, but because there was so heated competition between the teams and teams trying to find these last 2% of their servers and stuff like that. So I had to implement it as we went. And also we had a team that for some legacy, whatever boring reason, ran almost all of their servers behind NAT. When it comes to the connecting to this central collector. So for them, I basically just extracted IP address information from the message itself and then correlated that. But findings, in our case, we managed to end up with, how it is, 92% of the servers were patched by 4 o'clock. Now, if we exclude the incorrect CMDB data because there were incorrect CMD data for sure. If we exclude that, we can understand, well, yeah, we reached 96%. Now we found that, okay, we have some servers in our DCs that actually the application was run on, but there was no data in the CMD whatsoever. We had 208 of such records, and we have also more servers that are actually running in our let's say customer data center, because we also operate IT services for the customers. So some teams ran the script on some of the customer servers as well, while we have previously said that all the customer servers are out of the scope. So the scope was only our internal stuff. And yeah, we only had a couple of people, so me and some how do we call them? So we have people responsible for the whole overall crisis process, like process managers. And all the managers and whatever, they had no idea, so it came as a surprise. So yeah, our CTO knew about it. I made her a hint saying that I will organize something that will ruin our people's day, and she said, yeah, fine. And also we had like support requests coming in because we didn't have binary for some Solaris boxes, for example, but we still have like 6 Solaris boxes. So we asked them just the data dump from these boxes to actually understand can they log into these devices or not. And then some other good findings that I want to share is that, okay, statistics, so like which operating systems we have, the manual and multi-IP is just like copies of the same servers, but the ratio between Linux and Windows is what we have in our data centers. The top users is painting a really good picture about which users ran the application. Obviously the root is the #1 user. And then we have this Valve admin, which is kind of like a duty administrator. So it's actually an Active Directory account. And this kind of made me ask the question, so how come that this user patched servers from 10 different teams? So how is that possible? Because like all the servers should be independent, teams should be independent. So what they did is they have some sort of account sharing, or they use this account from legacy times, and now multiple teams use that Active Directory account. So this way, actually the teams would be able to access each other's machines. So not really secure. All the other people are like our own users. What we also can see is that the policy we have is, and that everyone should have, is that if you have a Windows Active Directory and you have Windows machines, even if I have like my employee account there, this employee account shouldn't have any administrator rights on any of the servers, and there should be a separate administrator user. And you can see that there are users like Hannes admin and Aare admin and Tanel man, and these are all these called admin accounts. But the Fred Brew and Artlov and Martsi are typical Active Directory person accounts that shouldn't actually have administrative rights. So again, one thing that we had to fix. And we didn't really knew before, so what's being used and how it's being done. And the top 10 paths as well, so where this application was run from. So this can also again paint some insights, so which users actually ran the stuff, because on the Linux everything is run as root, so we don't really know which user it was, but if we look at the paths where the binaries were, we can clearly see some of the users there who were running these applications. And that's about it, I believe. So we ruined our people's day. It's not the presentation that we are so cool, but it's more like how did we approach this problem to verify that we have ownership for all of the servers in our data center, so we don't have legacy stuff. We actually shut down over 50 VMs after this exercise that were just there without any owners. No one claiming them, no one running the application. We just shut them down and nothing happened. And I think that everyone who who actually have like similar stack, and this also works with public IPs, private IPs as well. So they could actually run the similar exercise, writing the specific code, how to integrate with your CMD or whatever. If you know how to code, it's like a weekend hacking project. So it's not too bad, but the value you can get out from this for your IT stack and having an actual owners, should there be a real crisis, this is very valuable. And we were actually very happy that we ran this exercise. And that's about from me.
Thank you. That's really interesting. Any questions for Tarko? I see one, yep.
I have to congratulate you. That's rather impressive. I have seen something, a real life incident response in a quite large company, and weeks later it was nowhere near full. So this is rather impressive.
Yeah, we want to have the best engineering team, not even in Estonia, but we want to have the best engineering team in the world. So every day we work towards the target, so we actually would have the best network, best services, best people. So I think that kind of shows. So, but still, we of course, yeah, we were very happy, but we would actually wanted to be more on that 99% level, because all the work that we had done previously with our CMDBs and stuff like that. So
I thought it was particularly interesting the number of machines you were able to turn off as part of this exercise. And
yeah, and the CMDB records created, and also the CMDB crashing. So that was unexpected.
The same amount of unexpected delight you get from deleting code. It's a real pleasure. It's better than writing it. Are there any more questions in the room? No? Okay, well, thank you again one more time. Thank you. Now, Markku from Arista. Yeah, great. Thank you for coming along. Arista are one of the commercial sponsors for this meeting. So we're very, very grateful to them for providing the sort of support that allows us to operate this meeting. Perfect. All right. Over to you, Markku. Thank you.
Thank you. Can you hear me? All right. Hey, my name is Markku Rantanen, and I'm from the sponsor side. So I will show colorful slides. Quite many of these interesting slides were just text-based, but I'm from the vendor side, representing Arista here. So my background is really long-term, from historical. I was the first technical SE in Cisco Finland in '95. Then I was the first SE in Juniper in 2001. And since last fall, I've been the first technical person in Arista Finland. So any bets for the fourth one? Anyway, so you can find me in IRC as well if you want, and that's my email address and so on. The logo here, what do we do? If Arista is not so known to you yet, so we build clouds. And this is a logo from Cloud Builders event that we run 2 times a year. So I chose it from there. So I'm using the opportunity here to tell what Arista is doing and what we are selling. By the way, is this actually is not here? So this looks like this is not the PowerPoint. This is just the PDF file. So I have some animations. Let's see how they work actually in a couple of slides. So what we are selling hardware and software. And here we are representing the slides. This slide is representing the 4 quadrants of different style of devices that we make and sell. So we have modular devices and pizza box style of devices, and then we kind of categorize them into volume and value type of devices. So regardless of what kind of a device it is, any device can be used as a spine device, or it can be used as a leaf device. And so while we have the value and volume based, so we have different ASIC versions of similar looking devices to be used in custom use cases selectively, but we don't differentiate the use case of being at the spine or leaf device based on the size of the device. It's rather what's inside the device that is dividing it to, or actually is making the use case for it. So we are building a different, many different kinds of hardware devices for different use cases, but we only have one EOS operating system, which is underneath this cloud here. But there's some text, but the animation is not working here. Anyways, it's saying that we have one single binary image, which means that we have single binary image. So you can copy even from any of the switches to any other switch in the network and still running the same software. So we really have one single image. So we just don't have common name for the operating system, but we have one single image that is capable to be used in any of the devices. Our operating system, I will be repeating it 20 times here, is based on standard Fedora Linux, and it's unmodified, so it's standard Linux. So our operating system is running as just like one application in Linux. So anything that you are familiar with Linux, you have it in the switch. So basically, our devices are Linux servers with a lot of wire rate fast interfaces. So where our devices are being used in 8 out of the 9 big cloud operators. So all these Googles, Facebooks, and Azure cloud services and big data center customers are our customers, and they are building heavily their solution based on our gear and software. Our model is to offer a simple solution, simple architecture, which is always standards based. So we have never created any vendor proprietary fabric which excludes or vendor locks in the customer to use that specific vendor. So we don't have any fabric design that prevents customers to use other vendors in the same fabric. And also we, in that way, can be implemented in other vendors' open fabrics if they have ones. So this one is just showing you the either layer 2 or layer 3 or virtualized network, VXLAN-based network, EVPNs, etc., or cloud-based implementation. It's always based on the same architecture, which is open leaf and spine architecture. Leaf and spine is something that we actually invented together with Microsoft. So we actually were building Microsoft Azure platform and invented that this is the way to build the data center network. So using spine devices and leaf devices and making routing-based infrastructure and then running the services on top of that. So that story starts from 2008. Some people say it's a pity that we didn't trademark leaf and spine, but then it would perhaps be vendor-specific model in that case, so better leave it that way. So use cases where Arista devices are being used. So we started in a data center only. So, but today we are being deployed in many environments. So data centers are, of course, many forms and many form-like use cases. So both in small and large-scale data centers, data center interconnection, also routing, internet exchange points, as that is mainly the topic today. There we have had devices shipping since 2016, so we are making also routing solutions. We don't make routers, specific routers, but we make switches that can do routing. So it's more like the same operating system, but you can pick and choose the right model to do the routing. I have a couple of examples, other integrations and use cases in later slides. One of the examples is cloud deployment. So we have launched something called AnyCloud, which means that we deploy the virtual router-based solution, which is the same image that we are running on our hardware devices, into cloud operators' offerings. And in this example here, the private premises data center is expanded in the same architecture into the cloud operators in Amazon and Azure or Google in this case, and also the peering between the private premises and the cloud premises is happening via Equinix based cloud exchange points. So our hardware is based on third-party silicon. We don't make any ASICs by ourselves. So we make the switches, we design the switches, but we use our merchant silicon. We have all of these on the table. So we have, people are saying, are you a Broadcom house? Well, yes, somewhat. But then we have others as well, like Dune Networks, which is owned by Broadcom. So anyway, so we have Broadcom and Broadcom and Broadcom. And then we have something called Cavium. Cavium is more known from CPUs, but they make also programmable forwarding chips. And then latest one, which we announced last week, new products, is based on Barefoot's Tofino chips, which is interesting switch that it essentially doesn't even know what's an Ethernet packet unless we tell it to what's an Ethernet packet. So it's completely programmable 12 terabyte per second platform that can do, for instance, thousands of or hundreds of thousands of VXLAN tunnels terminating to it, or DPI packet inspection. It could perhaps even work as a firewall if you want to. So it's basically a platform that if customer has a use case that can you make this device do some tricks, and then we can make it do tricks. So we can program, it's actually programmed with P4 language, and can be instructed to do anything. So if you're Googling it, it's Arista 7170 platform that we announced just last week. So other platforms, what we have, they are using these different ASICs, and the use cases are actually telling which platform to use based on which kind of ASICs they have built in. So we have the volume-based platforms using Trident chipsets, and then we have the more mission-specific use cases for certain ASICs are using Dune Networks, Jericho chipset, and so on. And those are used in perhaps in routing environment or other type of environment using the Dune Networks Jericho chips. So then people are asking quite often from us that how are you any different than any other vendor who is using also the same Broadcom chips? We are saying that not all hardware is equal, even though they are using merchant silicon. So what we do differently there is that we actually don't use the chip vendor's SDK at all. Well, we use some pieces of it, but mostly we write everything from our own use cases into that SDK and make the merchant silicon to behave differently. So that's from the hardware. The software is, as I mentioned, we have single image, and it's based on Linux, and that's one which makes us different than the others in the market. But then the architecture of the operating system is completely different. So we have something called state-oriented architecture in the software, and this means, this is by the way heavily marketing department fine-tuned slide of how the architecture is actually working. So unlike other operating systems, we don't have any inter-process states between the processes, which means that we have something called a system database inside the operating system, which means that any state that the device has, or any protocol state that the feature and the switch has, is written into the state database. And if any other process needs that information, it doesn't talk to the other process. So it is asking that information from the database. And that way we can make all these software upgraded, restartable processes. We can patch software easily, just upgrading the feature to a new version in case if you need to have a remedy on the software in a live environment. So this is something that we started this way, the whole operating system, since day one. And as a side effect of this one, because every state that any protocol, any instance inside the operating system has is in a database, we can actually stream this database out of the box. And this is something that is quite unique, that we are streaming the database in real time to its receivers, and we call this telemetry. So we have real-time telemetry triggered after any change in any protocol, any counter in the system. Then we are streaming the change of that database to telemetry receivers. So that's something which is unique. On top of that, it makes the development easier. So where you can run our operating system, of course our devices itself, embedded into the system, and also we have virtual images that can be run in any of the cloud operators, and of course in the hypervisor in virtualized platforms. And then we have containerized containerized version of the EOS available as well to be used in cloud offerings. So many of our customers are using all of these combinations. And like versa, in the opposite way, you can run your own applications within our switches, because our switches are at the same time Linux servers. So with given the resources the server or switch has, you can run your virtualized environment inside our switches at the same time. This makes coding, scripting quite fancy, that the same Linux environment that you have in a DevOps environment is actually within your switches as well. So anything that you're familiar with Linux environment, you already have it in the switches. Couple of open, Arista is open. It means that it's open to do anything, because it's standard Linux that we haven't actually touched anything except in one way. We had made one kernel module to allow the CPU to talk to the ASIC interfaces. So that's the only difference there is from standard distribution. So a couple of examples, more like commercial examples here, what we have done. Because we don't really compete except with the other hardware switch vendors in the data centers, but we don't compete with firewall vendors. We don't compete with the other players within the data center market. So that's why we are actually pretty open to any others in that area. Here's an example: Arista and VMware doing some things together. We actually started to deploy, to design the VXLAN. So the VXLAN draft came from our CTO and VMware together. So we have pretty extensive integration within VMware environment as well within our switches. So we basically have visibility into the switches that what happens within your ESXi hosts. So we have all the statistics, what happens at the VNIC level, VM level. We know where your VMs are. We know where your ESXis are in the network. So from network operator perspective, you have visibility how your VMs might be migrating in your network. So you have tracking capabilities and abilities, also statistics collections and so on. Also, when you create new VMs and you need VLAN trunking from the ESXi host to the switches, you don't have to touch the switches at all. So VMware vCenter actually configures the switches with corresponding VLANs and also prunes them out if you don't need the VLANs anymore after migrating the VM somewhere else. Also NSX integration. So basically when in NSX environment you create a logical switch and you need to have a hardware binding for that logical switch, that configuration to the switches, the hardware VTEP configuration is automated. So you don't have to configure the switches at all. Quite many of you may have experience of using scripts in the networking devices to automate the configuration. This is a little bit different kind of automation. It's left to the third-party controller to use the APIs of the system to pass the parameters to the actual configuration that needs to be changed. So you don't need to create any scripts in this case. You can do, of course, if you want to, but this is the commercial application or controller integration into our systems to make to basically avoid using daily configurations in the switches. Here's a graphical illustration of what I just said. So basically in NSX, if you have a logical switch and a VM, so you can integrate that into the hardware VTEPs for the bare metal devices without touching the switches at all. OpenStack, same thing. As this is a PDF presentation I'm running, I have 3 different sub-slides in this one. So basically it's showing the glimpse what does it mean. So basically the APIs in our system actually can, in the same way as in NSX environment, can get the by using ML2 plugins in OpenStack to get the parameters, how to configure VLANs or VXLANs or VNIs into the VLANs, if you or the SVIs to the VLANs, if you need to do routing between the VLANs and so on, all in an automated way. Likewise, in the vCenter use case, you have the visibility to the VMs and the VNICs and the logical switches and so on. You have in this case, visibility to the topology, what VMs you have in your OpenStack network and so on. So basically, as here you can see LLDP discovery of the VMs and so on, and also the network. So we basically have in both ways automation from the controller in exactly in the same way as you have in the vCenter and the OpenStack or any other controller perspective. So I don't have all the examples here, but we have automation with Nutanix as well, and Nokia's Nuance and so on as an example. Security automation. This is interesting. Everybody knows what's microsegmentation between the VMs, east and west type of traffic. And then in the physical world, you have on the top of the slide, you have this perimeter firewalls that are mainly used for north and south traffic control. And then you are missing something, the east and west traffic control in easy manner between the physical devices or physical devices and VMs in the network. So how to do that in automated way is something called macro segmentation. So exactly like the micro segmentation is automated firewalling between the VMs and the virtual networks in a virtual environment, then how to combine that one in an automated manner in the bare metal environment. So how does it work? Today it works with Palo Alto firewalls, and after summer it will start working with Fortinet and Checkpoint as well. So it means that their firewalls and their policy managers actually have an API where our controller can hook into. So we are using the API of Panorama, for instance, or Palo Alto's firewall, and we check that if we have a certain firewall policy that is matching our name tag, and if we have that one, we instruct via OVSDP our own devices to act accordingly. So basically we are using the form of open flow, but without any controller. We are using something called direct flow, which is translating the VLAN IDs, etc., to a service VLAN, which is actually using a automated VXLAN tunnel to the firewall. So basically, again, you create a new firewall rule in Panorama or Checkpoints or Fortinet's firewall policy manager, and you don't have to create a new VLAN or VXLAN manually into the network in order to, if that is a new host that never existed before, to have a reachability to the firewall. So how does that work? Like in the picture. Follow the arrows. Anyway, so this is the little bit more technical representation here. Here you have two hosts, host 1 and 2, and they are located in the same VLAN in two different switches. Without any firewall policies, you would have an access between those two hosts. And but if you want to have a policy that I want to control from the firewall perspective that these hosts are not able to talk to each other automatically, you can control it via firewall. But they happen to be somewhere in the network. You don't know where they are. And now in this case, just the IP address and protocol is being specified within the policy, and the other system, which is the CVX here with the Cloud Vision, is actually talking to the switches, creating service VXLAN and doing the mappings between the VLANs to the service VXLAN, which is forcing the traffic to follow the path to the firewall. So this is again an example that you don't have to touch the and configure the devices for daily operations. You have to configure the devices when you bring them up, and the foundation of the configuration is to allow to use these kind of automated works. So basically then you could, the regular network engineer who's configuring VLANs and IP addresses, etc., can focus into something else. Automation and visibility. I think it's in many of the presentations today being used clever scripts and so on. Our customers are pretty clever, and we have different type of customers. We have these do-it-yourself type of customers that uses heavily our SDK and write their own stack on top of that, their own protocols and so on. Then we have not so so much do-it-yourself, but using heavily DevOps and scripting and our automation tools in the middle. And then we have more regular customers that use turnkey solutions from us in order to do automation. That means that we have built-in apps that do automation and creating fabrics, etc. Example of the do-it-yourself type of customers was Spotify in Sweden. They realized a few years ago that 95% of their customers' traffic actually fit into routing table, which is less than 20,000 routes. And then they realized that why do we pay so much for these routers that can support million routes in hardware? Because our routes, 95% in the use case, fit into 20,000. So they wanted to use something called BGP selected disk download feature in our switches to program by learning the routes the new entries in the routing table. The problem was that we didn't support that feature. So they used an open source version of BGP selected download and used the SDK to install it on the Linux and was able to run within our system. That's sort of do-it-yourself type of a thing, and the best part of it is that our tag supports it. So they don't support how to make that code, but they support how you can make your own code to be run in our switches. So for these customers who are not that clever, who can make their own apps on the fly, we have something called Cloud Vision, which integrates all these things together. So we have there this macro segmentation, for instance. We have this, it's a platform where you can either use the built-in apps, or you can create your own by scripting using Python and creating simple configlets in order to fulfill your configuration and automate that one. And also it has a built-in telemetry support for this system database that is streamed of the device. But many times when we meet customers and start discussing about automation, so we can honestly ask what's so different between the configuration of the network between 93 and 2018. The only difference is that instead of Telnet they're using SSH, and they still do it via CLI. So that's the pretty much the if the network is small, quite many people do it this way, or at least they get the first incarnation of the configuration of the network design by this way. Nevertheless, you can pick and choose any of the APIs or methods how you do automation, and EOS really has many APIs. It's as I said, it's a Linux server that you can, if it doesn't have something, you can install anything. It supports standards RPMs to extend your apps in the system and so on. And as said, we have SDKs for more advanced users and customers to develop even their own stacks. An interesting point for how people are using automation. What's the most boring stuff to do? Is reading release notes. Do I have this bug? Or am I impacted on this severity or not? You can automate this. And one of our customers who saw this first time said that, now you save 2 weeks of my time every month. So basically, having a big network, a lot of release notes to read through, do I have this bug or not? You can automate it. So we have JSON formatted alert page in our web page. You can make a script that downloads it every day, for instance, and imports into the system. And this is a live reporting system in a way that if you enable BGP that you didn't have before enabled, and you have a bug in BGP, it will report you in just in that case that you have a bug, this bug in BGP. But if you don't have BGP enabled, it doesn't bother you with the feature or the bug that doesn't which is not impacted in your system. So that's an interesting thing. So it's a completely Linux-based extension in the system, and can email to you or change config or whatever, can give you a report and so on. About telemetry quickly, I think I have 1 minute time. So telemetry is something that we have customers that have publicly said that they're going to kill SNMP out of the network, and not that many customers have actually done it. Only few have killed SNMP, so they're trusting really only into what happened, what they can do with fully in automated way or in telemetry perspective. So basically, we have options that you can use OpenConfig based models and wait. Because OpenConfig is slow process, it's standardized, and you have to have these models. And some people think OpenConfig is equals to Google. Google basically says that what is OpenConfig and so on. But anyways, we support OpenConfig, but that's slow motion. What we have today is that we stream by using Google's RPC, though, the gRPC protocol to stream out all the database that we have within the system and get the visibility to what happens in the system. So you can use your own apps to read the data in the telemetry from the telemetry, or you can use our own apps, etc. But these are just examples that that how people are using it today, moving away from SNMP and other CLI type of pull requests compared to automated telemetry and so on. Okay. Thank you.
Thank you so much. There's some good stuff. Yeah, there's some really good stuff in that presentation that I've been using for a while. It's good. And I was wanted to say thank you again for being a sponsor of the meeting. It's very, very kind of you. It's very important that we get sponsors, otherwise we don't have such a good time.
Job from the Internets wanted to know, when will Arista support default external BGP route propagation behavior without policies so that it doesn't leak routes by default?
Wednesday.
And I take it Thursday large communities for BGP will be also supported.
Okay. I think we should take that question offline and check.
I think you mean online because he's not.
Yeah, I know, but I don't have the answer. I have to come back to that when we can. Do we have? I have to check it from the roadmaps and so on. But anyways, yes.
All right.
We can take it offline and write it down and reply to this person over the internet. Okay. Thanks. Anything else?
Okay. Thank you one more time. That's very kind of you. And 15:25, if everybody could return by then from the coffee break, if you'd like to see Jan's presentation. But for now, we have a coffee break. She's again in the lobby. Thank you. Thank you so much.